Welcome everybody to this NERA Connector webinar. I think we've got a really great topic today and a really relevant for the time as we look to a green recovery for Australia in the post-COVID-19 world that we will find ourselves in. So today we are delighted to have Simon Corbell, who was the chief advisor, he is the chief advisor at Energy Estate, but he was the former Chief Minister of the Australian ACT, and will share his knowledge on the concept of reverse auctions as a procurement process and how this process is successfully being used in Australia's renewable energy space. And we're particularly interested in exploring how it can be used in Australia's emerging hydrogen industry, which is a hot topic across Australia at the moment, and one that needs very careful thinking and some very smart brains to think about how we're actually going to support and create a hydrogen industry in the future. So before I get going, I'd like to do a welcome to country. It's important that we acknowledge the traditional custodians of the lands on which we are all meeting today right across our beautiful country, and pay our respects to their elders, past, present and emerging. A few housekeeping points before we get going. I imagine by now in the COVID-19 world that we are in, you are all familiar with the functionality of various webinar technologies, including Zoom, but I'm just going to give a very quick refresh. There are a number of buttons at the bottom of the screen. There's a Q&A function. So if you've got any questions for Simon, please do post them there, and I will attempt to get through as many as I can during the available time. So if you see a question you're also interested in, please upvote it, and then we'll be able to give priority to the ones that you're all most interested in. If you have any technical issues, please use the chat function to let us know, and we'll try to address them in the background. Before I let Simon take over, I just want to spend a couple of minutes on NERA and explain who we are. NERA is an independent but an industry expert-driven not-for-profit company, and our role is to help transform the energy resources industries in their broadest sense by working to overcome barriers and constraints to commercializing technology here in Australia for the benefit of Australians and for the world. We are building a collaborative and technology-led ecosystem with a focus on AI, automation and robotics, social license and decarbonisation of the energy sector. So I'd like to now welcome Simon. Simon is Chief Advisor at Energy Estate, and as I've said, has more than 2 decades of experience in public policy leadership, governance and implementation. He was most recently the Victorian Renewable Energy Advocate, and from 2008 to 2016 was the Deputy Chief Minister and Minister for the Environment and Climate Change of the ACT. His advocacy for a strong climate change policy for Canberra saw the ACT achieve national and international recognition as a best practice jurisdiction. He's widely recognised as a leader in the areas of renewable energy, climate change mitigation and adaptation, urban sustainability and public transport. He is currently an adjunct professor at the University of Canberra, an honorary associate professor at the ANU and a patron of the Smart Energy Council.
Thank you very much, Miranda, and thank you to everybody at NERA and all of your viewers today for the opportunity to present to you on this very important conversation about how we can leverage lessons from renewable energy procurement policy here in Australia into the, and indeed around the world, into the emerging space of the development of a hydrogen economy. As Miranda says, my background is as a recovering politician. I spent nearly 2 decades as a member of the ACT Legislative Assembly and Minister across a broad range of portfolios, including a significant period as Minister for Energy, the Environment and Climate Change, and as Deputy Chief Minister, where I was responsible for the implementation of the 100% Renewable Energy Program and the implementation of Australia's first reverse auction program, which has since been implemented widely in other jurisdictions, including in Victoria and Queensland. So it's a real delight to be with you today. Thank you for the opportunity, and I too would like to acknowledge that we are gathered on the lands of the traditional custodians of this country. And where I am in Canberra, I want to pay my particular respects to the Ngunnawal people as the traditional custodians of the country where the city of Canberra now sits. The subject of today's webinar is reverse auctions and lessons for the development of the hydrogen economy. And I think there is no better time to focus on how the development of renewable energy procurement in Australia has accelerated the development of utility scale wind and solar, and how similar procurement methodologies can be applied to the development of a hydrogen economy. Because in many respects, the challenges are the same. A nascent or emerging technology still facing a price gap in terms of the investability of the technology, still needing some level of revenue certainty, and still needing some level of intervention by governments or other actors to accelerate the technology to a point where it is completely price competitive and able to play its role in a broader decarbonised market. So I'm grateful for the opportunity for NERA to speak with you about these lessons. Before I begin, I'd just like to quickly outline my role with Energy Estate. Energy Estate is a clean energy advisor and accelerator business focused on clean energy projects and circular economy projects. We have a significant level of experience and 16 employees across 3 sites, Canberra, Sydney and Adelaide. And our focus is both on all aspects of the value chain in terms of advisory for renewable energy development, whether that's investors, whether that's equity or debt, whether that is a focus on technical development of projects, whether it's government and strategic engagement, or whether it's stakeholder community benefit sharing. We have a very strong suite of skills in this space, and around the country we're developing utility scale projects of significant size and scale, including the 4 gigawatt Walker Energy project in the New England Plateau, which has recently been highlighted by Beyond Zero Emissions as one of its top three projects for economic recovery in its Million Jobs Plan, or whether it's the 2 gigawatt Gladstone Central Queensland Power Project, which is designed to deliver firm renewable energy for heavy industry operations around that key Central Queensland industrial port, including meeting needs for heavy industry operations such as the existing aluminium smelter and cement manufacturing facility. So as a business, we focus very strongly on a broad range of both development and advisory mandates, and are closely engaged in the development of both utility scale renewable energy projects, but also its intersection with energy storage and new decarbonised fuels such as hydrogen. In this webinar today, I hope to address 5 key points for you. The first is a bit of an introduction and background on the concept of a reverse auction and the associated mechanism for procurement known as a contract for difference. I'd like to talk to you a bit about how the evaluation criteria adopted in a reverse auction program is implemented and why evaluation criteria is so critically important. Because as it is with any other procurement, design of a reverse auction process makes all the difference between success and failure. I then would like to highlight to you the types of outcomes that you can achieve through this procurement methodology for delivering ongoing benefits to community. That's both in terms of local content, local supply chain development and capability, local skills training, education and research, and also broader community benefit sharing and development and maintenance of social licence. It's certainly been the experience in the Australian context and indeed around the world that reverse auctions have significant capabilities to deliver these sorts of outcomes with a strong and focused approach. Finally, I'd like to talk to you about the lessons learnt from wind and solar reverse auctions in Australia and how they could potentially be applied, and some of the differences that almost inevitably will exist in supporting hydrogen development compared to supporting utility scale wind and solar. So let's dive into some of the detail. Some of you may have heard of a reverse auction, some of you may have not. But a reverse auction is effectively a form of competitive tendering that's been widely implemented globally over the past 1 to 2 decades to support development in the renewable energy supply sector in particular. It's probably worth stressing that the concept of a reverse auction is not specific to a particular technology or area of industry development. Indeed, reverse auctions are used in a very wide variety of applications conceptually around different parts of the global economy, but they have become to be best known in the context of supporting utility scale wind and solar development around the world, and indeed some other forms of energy development as well, such as biomass. So, and generally speaking, a reverse auction is conducted by a national or subnational level of government, although it can be implemented by a private procurer as well. And they have been extensively adopted in many countries around the world, which I will highlight shortly. In its most recent report on reverse auctions, the International Renewable Energy Agency, IRENA, identified there were 17 countries that were using reverse auctions in 2016. And while that report is now a little outdated, it's certainly a case that the number of countries utilising reverse auctions continues to grow. So what does a reverse auction do? Well, a reverse auction is a mechanism to deliver a value for money outcome and to award a legally binding entitlement through a power purchase agreement or a contract for difference or similar to enable renewable energy development to occur. So it's a form of competitive tendering that's designed to achieve the lowest possible price whilst also taking into account a broader range of other criteria. Auctions around the world have typically awarded development rights to support a particular level of renewable energy in terms of megawatt hours, or a certain amount of overall generation capacity, measured of course in megawatts. So, and certainly the experiences vary from jurisdiction to jurisdiction, but in places like Europe, for example, generally speaking, it's capacity that is awarded. In jurisdictions such as South Africa, it's often a certain level of renewable energy that is procured rather than overall capacity. Importantly, reverse auctions can incorporate a broader range of criteria than just price. Obviously, a reverse auction can drive down the cost of a particular product and achieve real market discovery of a particular product price, but it can also be used to drive or mandate other outcomes. And I think that's a particularly important learning in the context of the discussion we are having this afternoon, which is that it can incorporate both quantitative measures on price, but also qualitative measures such as local content, supply chain development, community benefit, social license and community engagement. So reverse auctions have the capacity to achieve multiple outcomes, and they are really a plug and play solution for policymakers and indeed for other sectors of a particular industry that want to try and drive very specific and purpose-built outcomes for their particular sector. So just have a look. This is the experience of reverse renewable energy auctions around the world by nation and region. And again, this data has been obtained from the International Renewable Energy Agency report. And if you're interested in the some of the deeper level of detail that's available around reverse auctions, I'd encourage you to go to the International Renewable Energy Agency website. They publish a whole myriad of reports and summary papers on the experience of reverse auctions, often nation by nation, including price discovery, pricing trends, implementation, lessons learned, and auction design. So there is a wealth of knowledge available that's published through IRENA, which is of course a UN body. So I would encourage any of you who are keen to dive into the detail to access that resource. But what you can see here is that renewable energy auctions are common across North and South America. Chile, as one of the leaders in the development of renewable energy in the Americas, partly because of its amazing wind and solar resource, has been a key driver and utiliser of reverse auctions, as has Canada, often at a provincial level or a regional level, what we in Australia would describe as a state or territory level. So in that case, a subnational level of government utilising a reverse auction framework. So quite a broad range of nations around the world and significant levels of capacity being awarded, often into the gigawatts in terms of the overall amount of development that's being supported. Just looking more broadly, then outside of the Americas, not unique to the developed world, also occurring in the developing nations of the world, including India and China, where there are very significant capacity releases occurring. Indeed, in India, we have an interesting situation where both the national government but also the state governments in India each run their own reverse auction programs. There is often complexity in that and governance challenges, but it shows that it's a tool that can be widely deployed at both national and subnational level. It's worth reflecting that this graphic and the previous page as well relate to the level of activity that IRENA analysed for the 2016 year. So at the moment you see that Australia is blank, and the reason for that is that there weren't any particular auctions occurring during that year. So one of the key factors that I think compels policymakers to look closely at the effectiveness of reverse auctions is their capacity to deliver outcomes on price. Obviously, with any competitive process, you want to drive down the cost of your commodity or your project. These are some figures again from the IRENA report that highlight how average prices have been driven down as a result of reverse auction activity. Now, this is not exclusively a consequence of reverse auction activity. It's also a recognition that over time the cost of technology has continued to fall. The levelized cost of energy from those technologies has continued to fall. But it does highlight that auctions have played an important role in helping to drive down pricing, and that the price reductions, particularly in solar and to a lesser degree wind, have been very, very significant. And I'll speak a little bit further in a couple of slides about the Australian experience in relation to large-scale solar in particular. Perhaps one of the most globally well-known experiences of the reverse auction process has been to support offshore wind development. Offshore wind development, obviously a very complex and technically difficult type of project development to deliver in a very hostile and difficult natural environment. But you can see here that the prolonged adoption of capacity releases, particularly by Denmark, in the space of supporting offshore wind, have dramatically seen dramatic reductions in the overall costs of offshore wind over time. Now, this is these figures I think are out to around the end of 2016, and you can see that US dollars per megawatt hour starting at $180 a megawatt hour, dropping to, unfortunately I can't see the bottom of the slide, bottom corner of the slide in my screen here, but it looks like it's sitting at around between $20 and $40 a megawatt hour by 2016. Since that time, offshore wind prices have continued to drop dramatically until they are now well below $10 US per megawatt hour in Europe. And indeed, in one of the most recent reverse auctions that occurred for offshore wind last year, negative prices were actually bid by bidders to receive entitlements for capacity through the Denmark reverse auction program. So this really points to how a sustained program of procurement over time can dramatically reduce costs. Here's a chart that's been compiled. Actually, the source is not IRENA, it's actually in-house within Energy Estate, and it's from a variety of different sources. But what it highlights is that the levelised cost of electricity versus auction or power purchase agreement prices over a decade-long period shows quite a substantial difference. Let's take a look, for example, at solar PV. You can see that whilst the cost reduction in LCOE, which is the darker line in solar PV on the left of the chart there, has been significant, and it's been driven obviously by the technological improvements in solar PV. The cost reductions for energy from solar PV when they are procured through a reverse auction program is even more significant, which is the lighter line and the lower of the two, down to 0.039 US dollars per kilowatt hour. That's a very, very significant cost reduction, and it shows that reverse auctions often deliver cheaper prices. The same is the case for onshore wind and for offshore wind, as you can see in that graph. And I'll talk a little bit more about the reasons for this a little bit later on in the presentation. But one of the key things that I would reflect on right now is that the contracting entities through reverse auction process are often entities with strong credit quality. They're often government-backed entities, so they're able to attract a cheaper cost of capital than projects in the broader market, often by a number of basis points, and that was certainly the experience in Australia. But one of the other reasons why the costs come down is certainty, not just credit quality. So reverse auctions are usually awarded under some sort of legal framework, often a statutory framework. And as a result, they have a binding quality to them that gives investors certainty, along with the contracting counterparty, that enables them to finance them at a cheaper rate and deliver, as a consequence, cheaper prices, both for the end consumer, but also the capacity to deliver projects more cheaply during the capital intensive phase. So it's a very, very important influencing factor, I believe, for policymakers when they consider the use of reverse auctions, is the capacity to deliver cheaper projects, cheaper project finance than you would in a traditional market environment. So what has been the track record for reverse auctions in the Australian experience, recognising that this is a part of a broader global trend over the last couple of decades? Well, the first reverse auction in Australia was held in the Australian Capital Territory in 2012, and that was for 40 megawatts of utility scale solar. That resulted in the awarding of the first contract for difference for utility scale solar in Australia, indeed for any utility scale renewable energy development that had previously only really been supported by grant funding at a state or federal level. That led to the development of the Royalla Solar Farm, a 20 megawatt project just to the south of the city of Canberra, within the borders of the ACT. And that became the first large scale solar farm connected to the national electricity market, and the largest of its type at the time. That was followed by a series of reverse auctions by the ACT government through 2014 to 2016, which ended up awarding over 600 megawatts of large-scale capacity, all for wind energy development across the broader NEM, as part of the ACT's procurement of green electricity to offset its carbon emissions and effectively achieve a 100% renewable electricity network. The experience of the ACT was influential, and it led to other jurisdictions choosing to adopt a reverse auction program. Victoria was next cab off the rank with the Victorian Renewable Energy Auction Scheme, which went out to market for 700 megawatts of capacity in 2017 and ended up awarding just over 900 megawatts of capacity, a mixture of utility scale wind and solar projects across Victoria in 2018. And finally, and most recently, the Queensland Government completed the conduct of its R400 auction, as it was known, for 400 megawatts of utility scale wind or solar, and that was completed through CleanCo, the Queensland Government-owned renewable energy business, in 2019. So a range of reverse auctions and experience of reverse auctions across different varying sizes of jurisdiction at a subnational government in Australia. So let's have a look at the experience of price. This is a chart sourced from information provided by the Clean Energy Regulator, and what it highlights is how we've seen costs for large-scale solar, LCOE for large-scale solar, continue to decline over time, and in particular the price discovery achieved by the first ACT reverse auction. So in 2012, the Bureau of Resource Economics estimated that the LCOE for large-scale solar in Australia was still sitting at around $220 to $290 a megawatt hour. When the ACT government, when I was the minister, chose to run the reverse auction, we were confident that the Bureau of Resource Economics estimate was wrong, that it was too conservative, that it was too cautious, and that proper market discovery, price discovery in the market through an auction program would deliver us a stronger result. Nevertheless, we estimated the costs of the scheme based on the BRE assessments. What we were very surprised by was the level of how much lower the market was prepared to go in a price discovery process through the first ACT reverse auction. And the first ACT reverse auction price was actually $185 a megawatt hour for the Whyalla Solar Farm project. Now that might seem high today, and it certainly is when you look at the pricing on the lower right-hand side of this chart, but at the time, that was a significant price reduction for solar, large-scale solar in Australia, much lower than had ever been anticipated. And it really shows the strengths of a reverse auction program in achieving proper price discovery in the market. We can make our estimates about the costs of a new technology, whether it's solar, large-scale wind, or indeed hydrogen. But there is no alternative, no better alternative than actual proper price discovery to understand what investors are prepared to pay and what they think is an investable price. And that was certainly one of the key learnings from the ACT reverse auction program, and we were delighted to see that outcome. Let's see if So associated with the reverse auction program was the awarding of an entitlement for renewable energy development, and in Australia and indeed around the world, that's generally been awarded through some form of what's called a contract for difference. So what is a contract for difference? A contract for difference is a form of revenue guarantee. Basically, it ensures that the price that has been bid by the proponent in the auction is guaranteed for a set term, and it can be indexed or not. It can have other variations associated with it built into a contract, but basically it's a form of guaranteeing a level of price certainty over a set period of time. And that's what really makes a project bankable from an investor and lender perspective. Generally speaking, the contracting government or consumer pays the difference between the bid or strike price awarded in the reverse auction and the cost of electricity in the wholesale electricity market if it falls below that level. What that means in those circumstances is that the purchaser or the awarder of the entitlement guarantees to make up any difference between the wholesale electricity price and the strike price bid in the auction. Equally, though, in an experience where the generator is achieving a strike price in the wholesale electricity market, a sale price in the wholesale electricity market, which is higher than the strike price, that means that the purchaser of that product, the awarder of the contract for difference, is in credit and is either paid back the difference between the strike price and the higher price in the wholesale electricity market, or credits it to that entity against future losses. So it is a very effective mechanism that over time provides both price certainty for investors, ensuring bankability and attracting that lower cost of capital that I mentioned earlier, but it also means that consumers benefit because they achieve lower prices and indeed lower levels of subsidy overall if the CFD strike price is set at the appropriate level. So let's have a look at the experience of one of the ACT reverse auction projects, the Canoe Bridge wind farm, which was supported by Wind Auction 2 in the ACT. And this just gives you an example over a period of a month of the payments being made by ACT electricity customers to achieve the strike price achieved of just over $80 per megawatt hour. And also the payments being made to ACT consumers by the generator of the Canoe Bridge wind farm, which is owned by WindLab, where the wholesale electricity price is higher than the strike price. You can see for the period of July, obviously a very windy winter month, ACT consumers, generally speaking, did not have to compensate the owners of the wind farm for prices below the strike price of just over $80 a megawatt hour. And for most of the month, consumers were actually in credit. What this means is that the overall, if you achieve this type of outcome in an enduring way over a period of years, you actually achieve very significant price reductions for consumers to achieve a transition, in this case, to an 100% renewable energy future. And that's been one of the great successes of the ACT reverse auction program, is that the strike prices have been set at competitive levels, and wholesale electricity prices have meant that generators have, generally speaking, seen lower levels of compensation from consumers and higher levels of credit going to ACT electricity consumers through the ACT distribution network business. I'd now like to turn to some issues around auction design, because I think this is critically important. It's one thing to run a reverse auction, and it's another to design it well so that you achieve a range of important outcomes. You want your project, obviously, to deliver competitive prices to reduce costs to consumers. You want to make sure that your project proponent is able to deliver and has the technical capacity and financial capacity to do so. But you also want to make sure that your proponent is able to deliver a broader range of benefits. And one of the experiences in the ACT and Victorian reverse auction programs in particular is that strong focus was put on community engagement and shared benefits, and also economic development outcomes for those jurisdictions. Taking a step back, I think it's really important when we reflect on the clean energy transition that we recognise that the global flows of capital that are occurring in this space are just massive. They are in the trillions of dollars, particularly when you project them out over several decades as we see the decarbonisation of the electricity supply sector and associated carbon fuel sector. If we're going to see that level of flows around the global economy, it's important that the benefits that accrue from those flows of capital are shared and are shared equitably and shared broadly across communities and economies. So it's not simply in the hands of the owners and investors in projects, or indeed the project developers, or indeed those who purchase the electricity or other products, but the broader economy as a whole and broader communities as a whole. And that's particularly the case when you think about utility scale developments like these that often occur in regional and rural centres. We have to make sure that the benefits are shared. We have to make sure that the opportunities are spread to as wide a field of people and places as possible. So that's why here in the criteria that I put up on the screen from Victoria, from the Victorian Reverse Auction Scheme, emphasised very strongly and gave significant weighting to economic development and community engagement outcomes. So the way this worked is that there were 5 clear evaluation criteria that the Victorian government used in assessing the merits of projects bidding for the Victorian Contract for Difference. And then in addition to that, there was a price consideration which was addressed separately. And then they were brought together to achieve an overall value for money assessment. If you just assess a project on price, you're not going to get these types of outcomes. If you just assess a project on these types of outcomes, you won't necessarily get a competitive price. You need to align the two, and you need to design your auction and your evaluation criteria well to achieve that. And that certainly was the experience in Victoria and in the ACT. And if you look at the weightings associated particularly with evaluation criteria 3 and 4 in the chart on this slide, you'll see that overall the weightings for those two outcomes amounted to 40% of the total weighting score for performance in these criteria. So that really sends a strong signal to your proponents and to their investors that if they want to achieve an offtake from a state government, for example, they need to deliver on really meaningful economic development outcomes, really meaningful shared benefits in local communities, and with a strong focus on social license, where they've built community acceptance for their project, and it's not a case that a project is being fought against by the local community every step of the way. And I'll speak a bit more about some of the economic development outcomes that we saw in the Victorian program shortly. So here they are. In the ACT, to start with, there was over $500 million of direct investment over a 20-year period into the ACT economy. And that focused very strongly on the ACT's economic strengths, which are around skills, research, and knowledge-based economic activity. So, for example, businesses like WinLab invested in Australia's first master's level course in wind resource mapping. And that was a direct outcome as a result of the ACT's economic development criteria in its reverse auction. The French renewable energy developer Neoen invested in Australia's first wind turbine skills maintenance course at the ACT's Canberra Institute of Technology, a TAFE level training facility. In Victoria, the numbers are even more impressive, recognising the size of the procurement and the size of the jurisdiction. But capital investment of over $1 billion, ongoing operations, spending in the local Victorian economy of over 700 million, around 900 new jobs, 600 ongoing jobs, including a very strong focus on apprenticeships. But I think what I find even more compelling about the economic development criteria in the ACT and Victorian schemes was the types of innovation we saw from renewable energy developers in response to the requirement to address those outcomes. This is a little screenshot from a story in car sales, which I tracked down. The ACT will shortly open it's the first public hydrogen filling station in Australia. Unfortunately, it's been delayed from December 2019 due to a range of factors, but it's due to open later this year. And that will support a fleet of 20 Hyundai Nexo hydrogen fuel cell vehicles for the ACT government. Now, the important thing to stress about this initiative is not that it's a great example trialling hydrogen in transport fleets, although it is that, it's because the cost of this initiative was entirely borne by the renewable energy developer successful for achieving a reverse auction outcome in the ACT. It was part of their proposal to the ACT government to build research and learning and knowledge-based capability around hydrogen as part of the economic development criteria set out in the ACT reverse auction. So the supply of the vehicles, the supply of the fueling station, the electrolyzer and so on, all those costs met by NEON, the successful winner in the ACT reverse auction. So this is the type of outcome you can achieve when you specify these types of outcomes as a requirement of success for a reverse auction process. Similarly, turning to Victoria, there's a business in the southwest of the state called Keppel Prince, which is Australia's only domestic wind tower manufacturing business. And in response to the Victorian Renewable Energy Auction Scheme criteria and requirement for economic development outcomes, including a specific requirement on utilisation of Australian-made steel, Keppel Prince announced that it would expand its business footprint by an additional 50 jobs to meet demand associated with the Victorian Renewable Energy Auction Scheme. This is a great example of how mandating local content can grow jobs, particularly in regional economies, and build capacity. And finally, I'd like to really highlight the commitment made by Ausbestus, the Danish wind operations engineering and equipment supplier, who committed to the establishment of a wind turbine nacelle assembly and manufacturing facility at the old Geelong car factory in Geelong. That facility opened, employing over 50 people, and instead of shipping in wind turbine nacelles fully assembled on the back of a boat from Vietnam or China or Denmark, Ausbestus committed to assembling and manufacturing some of the components locally in Geelong in an old economy factory once occupied by Ford. For me, that's a great story of how you can try and create local jobs in local supply chains, develop new capacity off the back of specific economic development criteria. So what are the lessons? The lessons for reverse auctions in the Australian context is, first of all, they deliver bankability for projects. The price certainty and the legal certainty associated with a reverse auction awarding a CFD allows those projects to move forward for investment. Secondly, they achieve real price discovery. And for new technologies and emerging technologies, whether it's utility scale solar or potentially for hydrogen fuels, that's a very important mechanism to move beyond the hypothetical, move beyond the price projection, and see what investors are actually willing to accept in terms of price. Thirdly, it can mandate and support local supply chain development, as I've just outlined, and the benefits there are very, very significant. Fourthly, it can deliver co-benefits in skills training, in research and development. And I think one of the great lessons that the ACT government has learned is that this is a really exceptional way to leverage private investment into public research and education institutions, such as our universities, such as our TAFE sector. And that commitment is ongoing. Most recently, the battery storage and grid integration program at the ANU is financed through a multi-million-dollar grant from the ACT government, which is entirely made up of receipts from commitments made by renewable energy developers in the ACT reverse auction program. And finally, I really want to emphasise it can help build and enable social licence. By requiring utility scale projects to perform well in addressing community engagement And in Victoria, there was an entirely purpose-built community engagement model that they expected renewable energy developers to meet. It can ensure that projects achieve long-term social and community support and maintain their social licence through both construction and operational stages. There are, of course, some key differences to take into account between wind, solar and the broader renewable energy sector and the development of new fuels such as hydrogen. Obviously, with wind and solar, these markets, particularly the electricity market, is an established market, it's tradable, there's clear demand, and the technology itself is mature or rapidly maturing. In comparison, hydrogen, it's an emerging market, it's nascent in terms of its potential application across different parts of the global economy. But there are comparable established liquid fuel markets, and there is a need to accelerate demand for hydrogen. And that's where providing an offtake, providing a guaranteed price for a particular fuel by a contracting entity, either for domestic supply or for overseas supply, is an important opportunity. Clearly also there are still emerging technological barriers associated with hydrogen development, in particular its transportation. But again, price discovery can help achieve some meaningful outcomes in terms of understanding what investors are potentially able to stomach as they push forward. So in closing, I'd simply like to reflect on some brief opportunities. Reverse auctions awarding contracts for difference to underpin price needed to achieve bankability could help to accelerate the development of hydrogen at scale. In particular, when you consider whether reverse auction should be focused on the renewable energy side of hydrogen manufacture to continue to drive down the price of electricity, to provide for that abundant surplus clean energy that's needed to really make hydrogen work as an affordable fuel, and then enable the costlier elements of manufacture to be borne by investors because of the bankability of the renewable energy development paired with hydrogen manufacture. The opportunity exists also for mandated requirements for local supply chain development. And I would say that regardless of whether or not reverse auctions are utilised in the hydrogen sector, mandating local content, even for grant schemes, even for government grant programs, should be front and centre. You think about the ARENA program, where is the mandated local content development, local skills development, local technology transfer and research capability commitments being made by successful proponents in existing grant programs? However modest they may be, they can make a difference, and they should be asked for as a matter of course when it comes to grant funding by state or federal entities. There should, of course, continue to be a focus on local skills development and research commitments that I just mentioned. And finally, there is the opportunity to mandate a requirement for building social licence. As the Finkel study into hydrogen highlighted, there are significant social licence challenges in relation to hydrogen development, whether it's issues around water scarcity and potential competition for water supply, whether it's issues around perceptions of safety and reliability of technology. It's important that social licence is built and maintained, and mandating a social licence obligation as part of a procurement process for a grant recipient or for the recipient of a competitive tender such as a reverse auction is, I think, a key opportunity to be considered. So I think that brings me to the end of my presentation today. I'd like to thank you for listening. Thank you to Nira for the opportunity. And Miranda, I look forward to a discussion to round out the hour we have available to us.
Thank you very much, Simon. That was an excellent overview of the reverse auction, and it's indicative of how interested people are, because there's some excellent questions that have been posed. So I'm going to try and sum up. So I'm going to start off because we haven't got that long, and I'll think about how we can get your responses to any questions that we're not able to address in the time that we've got. I'm going to ask a general one about the whole bidding process. And I guess I'll group about 3 questions that have been asked into a sort of a broad general question. So there's an issue about globally about speculative bids and about bidders being able to know their break-even position and testing the viability. And then there's one around, well, do the criteria, as much as we all strongly support them, how do they stack up in the economics in terms of the procurement costs? And then around the weighting of the evaluation criteria, how transparent is that to the bidders? And how are bids totally transparent in the same way as any other open auction? So general questions around the bidding process.
Yeah, thanks, Miranda. So first of all, the criteria must be transparent and must be known to bidders. It's very, very important that they know that. Otherwise, you just don't get that response. You need to tell them, obviously, the criteria, but you also need to tell them the weighting. And that compels a serious response on those key issues. So, for example, in Victoria, 40% of the total weighting was to 2 key criteria around economic development outcomes and social license community outcomes. The fact that it was 40% of the score meant you had to get that right, otherwise you were not going to win. So it was really important that there was transparency. In relation to unrealistic bidding, or in relation to bidding too low, or lack of deliverability, that's why it's very important to have criteria around technical and financial capacity to deliver. So in the this is something we were very conscious of in the ACT reverse auction experience. We were concerned that people would bid at a ridiculously low price, would look great, but they'd never be able to deliver their project. So we had a set of evaluation criteria, and so did Victoria, that focused on the technical and financial capacity of the proponent to deliver their project. So they had to be credible, they had to have credible contractors and subcontractors, their equipment suppliers had to be credible, and they had to have clear letters of support, both from debt and equity, about their capacity to deliver. So that really made a difference. And that was all put through a robust evaluation process by independent experts looking at technology, looking at track record of proponent, and so on, so that we could have a good level of confidence that they would have the ability to actually deliver at the price they said they would. At the end of the day, it's worth highlighting that if a proponent is unsuccessful in delivering a project under either the ACT or Victorian programs, they simply, or if they don't meet any of their key milestones, including their ongoing economic development contribution milestones, they have their entitlement withdrawn as the ultimate sanction. So there is every reason for them to meet their commitments, because otherwise they risk losing their revenues, and that obviously means the project falls over very badly from a financial perspective for them, not for the contracting government.
Very good. So in the time frame, I'm going to ask, I want to get one on hydrogen, but I'm just going to ask a very quick 2 questions combined again because of the time frame. So over what time period would a CFD typically operate? And that sort of runs into the second point, which is, when do you actually run an auction in the energy capability life cycle? And I guess the question then is a CFD time-based, and at what point do government remove themselves from the process? Yeah,
so tenor is very important, and in the early stages, the tenor of the ACT's auction contracts was 20 years. That was the feedback we had from the market as to the period of time that would be expected for a reasonable return on investment. That has shortened over time since 2012. For example, the most recent reverse auction conducted by the Victorian government was 15 years in terms of its tenor, and the awarding of contracts through Canoe in Queensland is even shorter than 15. So the tenor does go down as the overall LCOE of the technology improves. And that's appropriate, because it means the cost on, the return on investment can be achieved over a shorter time frame. In terms of when The important thing though is that those contract terms should be maintained. You know, it's not something you pull out of because costs come down. If you've committed to a price over a set period of time, you need to honour that. Otherwise, there's no bankability in awarding this type of mechanism. In relation to when should CFDs be applied, when should reverse auctions be run, I would suggest that they are best placed at the early stage development of a technology where it is close to commercial development. I don't know whether you would have said back in 2012 that $250 a megawatt hour projected for utility scale solar was the right time to be providing price support. But I think in hindsight, the clear answer is it exactly was, because it helped drive down the cost of utility scale solar very, very significantly in the Australian market. It achieved price discovery for the first time. And I think it needs to occur around that same stage in relation to hydrogen development as well, to help bring down cost and accelerate investor appetite to do more.
Yeah, which sort of that segues really nicely into we've only got time really for one more, unfortunately, but we will attempt to answer the questions outside of this session. So renewable energy auctions work well in Australia because there's a significant and established demand for energy via the NEM. Now, in the case of hydrogen, that's clearly not the case. There's a small and immature demand for hydrogen. So auctions are excellent at leveraging the supply side. In order to back that, we're also going to have a means to stimulate the demand side use of hydrogen, and whether that could be leveraged via any auction procurement process.
Yes, so I think you could equally apply it on the demand side as much as on the supply side. And indeed, what you could do is you could try and pair the two. So you could think about pairing supply with demand. So you could run an auction. You could run an auction that supported supply, but it would have to be done in the context of, as one of the criteria, that there was an off-taker willing to buy into that product if it was at a particular price. So if the reverse auction could guarantee a reduction in the cost of hydrogen down to a particular level, that would make it more attractive for someone to want to commit long-term to purchasing hydrogen fuel at that price. And then that could be paired together as part of the proposal put forward in a reverse auction CFD type context. So I think it's an excellent question. And there are nuances around that would have to be worked through, but I don't see conceptually why you couldn't do that. And my initial thinking would be you would pair the two, of supply and demand together in the offering through the auction, and that would actually be something that the auction would require as part of a condition for participation. Yeah.
I apologise, everybody. It's just such a fascinating topic, and clearly there's just so much that needs to be explored. So I would urge people to make contact with Simon directly and ask him the question. And in addition, if there's been some questions that we've been able to capture, we might get Simon to give a bit of an answer that we can put up on or share with participants in some way. So thank you very much. I realise that we're all giving an awful lot of our time to online connection, and I just point out before I go the beautiful painting behind Simon, which has a harvesting mechanical meaning, and it's lovely that in this world we get to see a little bit about the people that we talk to in this environment. So thank you, everybody. Thank you, Simon, very much. It's been really interesting, and we look forward to the second webinar, which will go a little bit deeper into some case studies, we hope, next week. And so it'll actually go to a little bit more of the nitty-gritty of projects than we've given the broad overview today. And we look forward to connecting with you all next week with Simon. So thank you very much, everybody, and farewell for the moment.
Thank you very much.